Hi folks, welcome back. How you all doing? Hope everybody's doing all right. Welcome to part 2 of Algebra solving first degree equation. Part 2 we're going to talk about solving equations with the multiplication situation, with the division situation. So it's going to get more fun. And today I had my coffee and my honey bun and I feel good. So let's go to work. One more time, algebra solving equation, first degree equation, part 2, talking about the other two cases, and the goal is the same. Get the unknown alone by itself on one side, and we're going to do some math actions, and through the math actions we'll do the same math actions on both sides. So remember all the rules, follow the rules, stick with the reality, do the correct math calculation, and you'll be successful. Alright, let's go to work. The first exam, the second, actually we did the first case, second case, and this is the third case. Third case is, if you see, case number 3, if you see multiplication, then what's the opposite math action of multiplication? Division. Then we divide. So then we do division. But this is a sensitive issue, and I have to show you case by case, and I have to show you different situations. I will teach different examples of how it's going to work out for you and how it's going to look on the paper. So if you see multiplication, we do the opposite of multiplication, which is division. Let's go to work and start with the first equation. And the first equation would be, this is the most popular of all. So when you see multiplication, for example, let's say we have a 4x equal to 32. So right here is 4 times x, and that's multiplication, then we divide. So we have to divide. But remember, we're going to do the division on both sides, so divide both sides. Alright, so we're going to do that. Since 4 is the coefficient of x and is attached to it, any number that is attached to the unknown, it is the coefficient and it is multiplication. So 4 is multiplied to x equal to 32. You look at the left side, and the goal is to get the unknown alone by itself. So how am I going to get the x by itself? Get rid of the 4. How do I get rid of the 4? If it's multiplication, I divide. Divide by 4. Since I divide here by 4, I have to divide this side by 4. So therefore, you say, now 4 and 4 cancel, and it doesn't give you 0 this time, it gives you 1. 4 over 4 is 1, 1 times x is x, so x comes out alone, and the other side you do the math. So x is equal to, here's my black marker, x is equal to, blue marker, x is equal to 8. And that's the final answer right there, you're done, finished. So you do the math on the other side. And that's the final answer. So if you want to know your answer is correct or not, you take the 8, which is the solution or the value for x, take the 8, put it back in here, do the math. If the left side gives you the same answer as the right side, you're good to go. But every time you plug back in the number, make sure you do the math independent on the left side and right side. Make sure you do the math independent of each other, because you want to compare the two sides and see if it's equal or not. But this was an easy one, so therefore, if you see multiplication, you divide by the same number that is multiplied. So divide by 4, not divide by 5, not by 2, not by 10, only the same number. Now, once in a while, you run into a situation that you end up with a fraction. Is it possible? Sure. I'll show you one. For example, let's say we have 12x is equal to, for the sake of being simple stuff, is equal to 20. So now you got 12 times x equal to 20, and you say, I'm going to solve for x, my goal is to get the unknown alone by itself. What do? Divide by the number that is coefficient of x, divide by 12. So we divide by 12 and divide by 12. Now, this side is going to give you x, so x come out alone by itself, so 12 and 12 cancel, x comes out alone. But on this side, on the right side, you have two options. One option is to reduce the fraction, and when you reduce the fraction, you divide by 2 or 3 or 4 or 5 or whatever is divisible. In this case, 20 and 12, I can divide by 4, and I get 5 over 3. So 5 over 3 is the final answer. Now you might say, should I leave it as 5 over 3 or should I change it to 1 and 2/3? You can change it to 1 and 2/3 if you want. So x is equal to 1 and 2/3. 1 and 2/3 is the exact same number as 5 over 3. But if you were to write it as a decimal, you can also write it as a decimal, which is equal to 1.6666 forever. And then you round it based on the instruction for round. All right? So it's easy. Sometimes you end up with fractions, sometimes you end up with mixed numbers, sometimes you end up with decimal. Anything is possible. But here, for the right side, we reduce if there is a fraction, and sometimes you get a small fraction, sometimes you get a large fraction, and this reduction I divided by 4. You can start dividing by 2, and then again by 2, or by 3, or 4, or 5. Just keep reducing, keep simplifying until you get the lowest term. So that's the lowest term, and it is very important that if you have a fraction, it should be in the lowest term. Lowest term means it is simplified to the smallest number. You simplify it to the smallest number possible that you cannot simplify no more. And in CBCC, that's what is expected of all the students to do. It is expected that you reduce the final fraction answer, reduce it to lowest term, and then if you want to change it to mixed number, that's fine. But both of these are correct. All right, so next is, let's do another one that is multiplication. And this time, but here is what I wanted to show you. Let me just write this one more time. If you have a 4x equal to 32, and then you say, okay, my teacher said, because it's multiplication, I divide by 4, and this side I divide by 4 on this side. Yes, that's correct. It is 100% correct, and you're supposed to do that. But only and only if a single term equal to single term. If you notice that, and this, both of them are single term. Whenever you have single term on both sides, you can do that. What if you don't have a single term? What if there is an extra term in there? If there is an extra term, you cannot divide. That's a special case, and that is underneath case 3. So the special case is if it's not single term, for example, what if it was 4x minus 8 equal to 32? Now you cannot divide. You have to get rid of the 8 first, get rid of the negative 8 first, and I'm going to show you that in a minute. All right, so let's do that. All right, this one is in case if you have 4x minus 8 equal to 32, and please remember at this stage you cannot divide. You cannot divide by 4 because you have the extra term. So first we get rid of the extra term. So first, this is the extra term, get rid of this first, get rid of 8 first, and then make it a single term, then you can divide. Alright, so let's get rid of the extra term, and what do we do when you have a subtraction? You learned that before, we add, because it's negative, you put positive, same number. So we add 8 to both sides, we add 8 to both sides. Now the negative 8 and plus 8 give you 0, 4x come out alone, 4x equal to the other side give you 40, so therefore now you have a single term, now you can divide by 4. Alright, so now we divide by 4, so the other side you do the math, and easily done. So now you have a single term, now you can divide by 4, and barabim baraboom, x come out alone, equal to 10, and that's your answer. So easily done, but you have to be extra careful, you have to be vigilant, you have to stick with the reality. So don't do anything crazy, don't do any stunt work, and do things step by step. So you cannot jump from here to here, you have to go step by step, and always remember, if you have an extra term, get rid of the extra term, and that's what we are supposed to do for solving equation, because we're going to keep the term with the x, keep the term with the unknown, get rid of the extra term. If it's subtraction, you add, if it's addition, you subtract. So you always do the opposite sign, and then on both sides, same action, boom, you get single, single, now you can divide and get the answer. Alright, now let's look at some situation that it gives you a crazy number. What if it gives you a crazy number? For example, let's say we have 1,000 D is equal to 5. 1,000 D equal to 5. And say, wait a minute, that's a big number. 1,000 D equal to 5, and you're supposed to solve for D. Doesn't matter, small, large, big, doesn't matter. You say, okay, this is multiplication, so you see, this is multiplication, you do the opposite. So since this is the multiplication of 1,000 times D, we divide by 1,000. You stick with the reality, do not divide by 5, because if you divide by 5, that's wrong. Because here you want to get rid of the 1,000, so 1,000 over 1,000 give you 1, 1 times D is D, so D is equal to 1 over 200. So make sure you do a good job in your math over here, 5 over 1,000, you reduce it, and you get 1 over 200. So reduce on this side because it's a fraction, or you can write it as a decimal if it's okay. So therefore, you always divide by the number that's multiplied to the unknown, whether it's a small, large, doesn't matter. You could have a decimal number, you could have a fraction, and all of that. Let me show you a decimal first, and then I'll show you a fraction later. Alright, so let's go to a case or an example that has a decimal number. I'm going to show you that in a minute, but you could write this as a decimal also. But let me grab my black marker. Alright, and write the stuff for you. What if I have, let me start with the decimal first, and then we go to the fraction. So decimal, for example, let's say I got a 0.8, but let me change it to 0.2, make it easier. Alright, let's go to 0.2. Equal 0.2 times x. 0.2x equal to 16. Alright, 0.2x equal to 16. We are solving for x, and that's a decimal. No problem. It's a decimal number, it's multiplied by x. You know this case number 3. If you see multiplication, you divide. So therefore we divide by the same number, divide by 0.2, divide by 0.2 on this side, divide by 0.2 on this side, and therefore here you're going to 0.2 is going to cancel, and x come out alone by itself, so now x is equal to, do the math on the other side, equal to 80. So therefore that's the final answer for x. X equal to 80, you're done. And if it's a big, large number, you can grab your calculator, grab a calculator and do it by the calculator. Don't forget, always stick with reality and divide with the number that is attached to x with the same number, and you'll be fine. So always follow up the rules, follow with the rules, and that's how you do it. Alright, now let's look at a fraction. But again, this was single term, single term. If you have extra term, make sure you get rid of the extra term first. Let's do this one. For example, let's say we have 2/9 of k plus 2/9 of k plus 7 equal to let's say 10, why not? Alright, this one, in order to solve for k, you get rid of the extra term. So once again, you have an extra term, let's get rid of the extra term, and that is a plus sign, so that's extra term, so we're going to get rid of it. It's a plus sign, so we subtract 7 from both sides. We subtract 7 from both sides, and now you have you keep the other term, you keep the term with the k and get rid of 7. So now we have 0 here, and that gives you 2/9 of k equal to 3. So do the math on the other side and you get 3. Now you have a single term. But you might ask, that's single term here and single term. Now you can divide by 2/9 and 2/9. I'm going to show you a trick. I'm going to show you a shortcut, a fast, easy way to get rid of the 2/9 and find the final answer in a shortcut. But before I do the shortcut, let's go traditional and say, okay, what if I divide by 2/9 here? Fine, you can do it. What if I divide by 2/9 here? Fine, you can do it. You can actually go and grab your scratch paper and divide by 2/9 on both sides. This will cancel. K comes out alone by itself, and you're going to end up with the answer that is k comes out alone by itself. That's going to be 27/2. Now, this is okay. Fine, because you divide here and you divide here. Now, how do you divide the whole number by a fraction? Well, you have to have learned that already in basic math. You have to know how to divide a whole number or a fraction or a mixed number by another fraction, and then do it this way. Now, let me show you another trick. This trick is very valuable, and I'm not going to charge you for that, so I give you free advice. If you have a fraction that is attached to an unknown equal to another number, I'll show you the trick. If you have 2/9 k equal to 3, and it's a single term, and if both of them are single, you can multiply this side by the reciprocal of the fraction. So what's the reciprocal of 2/9? The reciprocal is upside down. So it's going to be 9/2 and times 9/2. So if you multiply a fraction by its reciprocal, it's going to give you 1. 1 times k comes out alone by itself. Boom, boom, this gone, and k come out alone. So k is equal to 27/2, which is 13.5. And both are correct answers. So this is the final answer. Now look at this. The other side. The other side is 3 times a fraction. If you put a whole number over 1, you can easily see what happens. So 3 times 9, 27, divided by 2, 27/2. But if you have a situation that you can reduce, then you reduce it. I'll show you one. What if we have this situation? But remember, it has to be single term in order for you to do that. For example, what if I have 1/5 of x equal to 7/15? Okay, so I got 1/5 of x equal to 7/15. Single term. I can do the shortcut, and I'll show you the shortcut. It's very easy. Because this is a fraction, single term, there is no extra term. All you have to do is just multiply by the reciprocal of the fraction that's attached to x. So this number is attached to x, that's its coefficient, is 1/5 multiplied by 5/1. So if you multiply this side by 5/1, which is the reciprocal, you multiply the other side by 5/1. And this side is going to give you 1 times x comes out alone, and therefore the other side you reduce. How do I reduce 7/15 times 5/1? Very simple. 5 goes into 5 one time, 5 goes into 15 3 times, so now you have 7 times 1, 3 times 1, so the final answer is 7/3. Alright? Which is 2 1/3. So both answers are correct, and there it is. You reduce the other side if it is a situation that you can reduce. Alright, so therefore, this is a fast action. It's a good shortcut, but only if it's single term. Like I showed you before, if you have extra term, you always get rid of the extra term, then you can apply case number 3. Case number 3 says if you see multiplication, you divide. Even though you could have divided both sides by 1/5, but this is faster. If you have a fraction, single term, you can multiply by the reciprocal. All right, let's go to case number 4. And this is the last case. So case 4 says if, by the way, hold on 1 second, let me show you something else. All right, let's do one more example of division because of case number 3. I would like to show you one more example of case number 3 before we go to case number 4. And that is, what if I have 9x plus 14 minus 10x plus 3 equal to 15. Well, no, let's put 10. All right, and then we're going to solve for x. Here you have to simplify, so let's simplify. And when you simplify on this side, because you have more than, you got like terms, you got more than one x, more than one unknown. So we simplify, reduce, and simplify means add like terms. We add like terms. And when you add like terms, you're going to end up with negative 1x plus 17 equal to 10. So there it is after simplification. But the negative 1x may give you a little bit of trouble, and I'm going to show you how to handle it, how to knock it down. You don't have to write the negative 1. You don't have to write the 1. You can write negative x. So let's put negative x. But before that, let's get rid of 17. So we have a plus 17. We subtract 17 on both sides. From both sides. We subtract 17 from both sides to get rid of plus 17. So therefore this side is going to give me, this side is going to give me 0, and therefore that's gone, but this one is going to be negative x. Now I'm not going to write the 1, I'm just going to write negative x equal to, the other side is going to give me negative 7. The other side is negative 7. So remember, now this, some people say, oh, that's my final answer. No, don't circle it. This is not your final answer. The final answer has to be the unknown, positive unknown, not negative. So therefore, it's a must. You must get rid of the negative. So must get rid of the negative, must get rid of negative. Now, how do you get rid of the negative sign? Very simple. You can divide both sides by negative 1 or multiply both sides by negative 1. So let's get rid of the negative, and this is what you do. If you have a negative x equal to negative 7, you divide this side, let me write it in brown, you divide this side by negative 1, divide this side by negative 1, and therefore these two negative cancel, and I have x. And remember the rules of negative. Remember the rules of negative for multiplication, division, addition, subtraction. Negative divided by negative gives you positive. Therefore, is 7 the final answer. So there it is. Beautifully done. Everybody will be happy. Now we can go home and celebrate. So that's how you knock it down. Simplify. Get rid of, add the like terms. Then get rid of the extra term. Make sure you keep the x. And if it's negative, that's okay, keep the negative, then get rid of the extra term, do the math on the other side, and then you come back and get rid of the negative. Make sure you do not circle this. That's not the final answer. You always have to have a positive x for the final unknown, whether it's x or y or z or a or b or m or n or t or s or whatever. It has to be positive. Therefore, this negative is not acceptable. You have to get rid of the negative. And the way to get rid of it is get rid of the negative by divide by negative 1. Divide by negative 1 on both sides. All right? Very well. Let's call it wraps for now because I want to show you case 4, which is if you see division, then you multiply. I want to show you case 4 in more detail, plus extra bad situation, good situation, and complex situation. I'm going to show you those later. So we're going to wrap it today for the part 3 of solving equation with part 2. I'm sorry, part 2. So we're going to do case 4 later, but remember, negative is not the final answer, negative x. You have to divide by negative 1 on both sides, and don't forget to follow the rules of negative. Thank you. You guys are great. See you next month.